All right, here we go with problem 11. What we're looking for here is we're not concerned about the horizontal asymptote or the vertical asymptote. What we're concerned about is whether a hole is created in this graph. Basically, you have a line. Let's go right here. You'd have a line, and what happens is you can't have a value right here, so there ends up being this hole, this gap, something like that. Or whether there is a slant asymptote, where you have a slant, the asymptote, instead of being horizontal or vertical, there's one diagonally, and this line sort of comes and goes and skirts right along that diagonal, or what we call a slant asymptote. Now, this occurs when the top is one more degree than the bottom. Here, this is of degree 2, this is of degree 1. The top is 1 degree more than the bottom, so we think that it's going to have a slant asymptote. Now it will, as long as I have x plus 2 in the bottom, as long as this piece up top doesn't factor and have an x plus 2 piece. Because if it factors to an x plus 2, they're going to cancel out, and then it's going to be creating a hole instead of a slant. We're going to do this, and to figure out where the slant, where that where that diagonal asymptote is going to occur, all we have to do is take this and divide it into the top. Okay. Now, if we looked at this, we have to first, again, as I told you, make sure it doesn't factor where there's an x plus 2 and an x minus 2. This top does look like it factors. It looks like, to me, it's going to factor that minus 2. It's going to be an x minus 2, x plus 1 over the x plus 2. But you'll notice it doesn't have another x plus 2 to cancel out with. Now we can do the division. If we come out and it goes into it perfectly, we got to start asking some questions. But usually there's going to be a remainder bit there, and that tells us it didn't go into it nicely. So let's go ahead and do this division here. And whatever we get up here will tell us what the slant asymptote happens to be. Again, I know it doesn't have a hole because nobody's crossing out creating a hole. So hole-wise, there is none. There's going to be a slant. Let's figure out where that slant asymptote occurs. X goes into x squared, x times x, x squared, x 2x plus 2x. Remember, we're subtracting the whole thing here. X squared minus x squared, gone. A negative x minus 2x. That's going to be negative 3x there. Now I'll bring down my 2, the minus 2. X goes into negative 3x minus 3 times, minus negative 3 times x, negative 3x, negative 3 times the 2, minus the 6. Subtract here, that goes away, negative 2 minus, that gives me a remainder of positive 4. So you have your plus 4 over the x plus 2. Here's the nice part. We don't care about the remainder. This right here is going to be our slant asymptote. You and I, in this problem, are going to have a slant, this diagonal asymptote, at the line y equals x minus 3. That is where we're going to have this asymptote occurring. And some line's going to come and scurry right along it. There you have problem 11. There is no hole, but there is a slant at y equals x minus 3. Remember, it occurs when the top is 1 degree higher than the bottom. Not 2 degrees, not 3, but exactly 1. Otherwise, there won't be either one of these situations. There you have it.